Okay, so I'm with the Department of Electrical Engineering and Computer Science, and I think my interest is in statistics, and I think I'm going to speak here not because of my terrific background in finance. That's a joke. Um, but from my interest in statistics and machine learning, and I think I'm speaking on the behalf of an exciting effort that's going on in IDSS as a part of a newly found Center of Statistics. As I mentioned, my interest in statistics and machine learning, and in particular, I'm excited about challenges that various types of social data represents. It's a new class of questions that many of the statisticians have not seen historically. Financial data is a special class of these social data that's fantastic because there are a bunch of great things going for it. One, money, to begin with. But in addition, it's generated because of a complicated social phenomena, be it a complicated market which is generating it, and it's not clear sort of what is the right social model or behavioral model to think about. And maybe that's why nobody has cracked the nut of bringing the S&P down. And third is it's a very large amount of data, as we just witnessed in the last talk. So great set of challenges. As an academic, what I would like to have is free access to this a great class of financial data, and in some sense, that's one of the effort that I would suggest that sort of this center and finance sort of make a priority, and it sort of resonates very well with the last panel's discussion as well. That is, it would be great if we figure out how to share a very good set of financial data. Now, the data that I could get access freely is Bitcoin, so I'm going to talk about how to trade with them. And okay, so here is a quick agenda for my remaining 8 minutes. Tell you a bit about what data we used, what's a prediction question. A best way to understand prediction question in financial setting is, can you make some money out of it? And then finally, I'll discuss, again, how do we get access to good financial data? And there'll be lots of interesting questions from algorithm design perspective and the data sharing perspective. Okay, so here is just today's price, $423 and few cents. That's the price of Bitcoin. As you know, it's a nice cryptocurrency. 2009, somebody named Mr. Nakamoto created it. A market cap is $6.5 billion today. As a wise man yesterday told me that billions these days don't matter, but still some amount that matters. And there is some daily transaction, and since there's a reasonable amount of daily transaction, if there was any information in the data, hopefully people have at least low-hanging fruits are taken away. So the question is that after those low-hanging fruits are taken away, is there still predictability in this data? And if so, can it result into a meaningful strategy? Okay, so here's the data that set that we used. We have been collecting data from OKCoin. It's an exchange in China since Feb 2014. They don't have access to historical data, so you have to collect it. And so we have been collecting it since then. So now we have got a reasonable amount of data. It's a price of Bitcoin, but in addition, there's lots of other detailed information about from the exchange. Roughly billions of raw data points, not massive, but reasonable size. And as I mentioned, this is the today's price, and we converted this data into sort of for regular structure perspective into time series evenly spaced. Okay, so that's our data. Here is how it looks. I know sort of not right choice of color for this lighting, but hopefully you see that there is reasonable variation. And this is variation over a few months period. So it's not clear that sort of it's just a reasonable one trend that's going on that sort of helps you. So there are some challenges. Okay, now you look at this and you say, okay, it's a time series data. Let's open a textbook in statistics and let's throw all the methods that we know. There are lots of great methods. So you throw lots of great methods at it. And the best fit that we found was this. Okay, it's a variation of ARIMA, but sort of that's what it is. So now you look at it, and if I were to take sort of a 3-second poll, what do you think? How good is this fit?
Over this data or the next period?
So that's a good point. So this fit was generated by training on the little bit of history before. Okay, and then sort of course, you are sort of constantly tuning yourself a bit. So in some sense, this is a causal fit. So it's not a cheating. What do you think? Okay, my 3 seconds are up, and I haven't received an answer. Yeah, it looks great. That's the answer I was hoping for. Thank you. So now you've got great fit, so of course you can hopefully trade with it. And here's what happens. One way to sort of just understand how good the prediction is to use simplest trading strategy and don't make it complicated. Simplest trading strategy would be I'll keep a minimal position, -1, 0, +1 at any point of time. And at each instance, at each time, I will predict whether my price is going to go up and down, and depending on my position, I'll decide to buy or sell, and then sort of see how well I'm doing, okay? All right. Now, we did this with the model I just showed you, and that is this model. And unfortunately, we start losing money. Okay, so clearly there's something off, right? And what is off really, if you look at this model, it's beautifully tracking what's happening just a little later. Just shifted. And that is a problem. So then sort of you go back to a drawing board and say, okay, we know that all the terrific statistical analysis that we know about time series data does not work, so what should we do? They say, okay, well, first question you will ask is there an information in data? Maybe there's no information in the data, okay? So what do you do? Well, if you're somebody like me, you say, well, I know there are these great compression schemes that are temporal. So let's first just let me sort of take this data and run it through a compressor and see if data compresses. Actually, it does compress. It compresses more than 50%. Seem to suggest that I can just, even if I were doing some simple random betting based on this compressor's outcome, I might be able to at least gain positive amount of money. So I shouldn't be losing. Okay, so that's good. Now then you sort of start thinking, okay, how do I build a meaningful model from here? Again, one way to sort of, going back to drawing board, a reasonable model, one way to think about it is to say, given all the history, let me build a statistical model that will tell me what is going to happen in immediate future. What's the problem with that? Well, just the way I described it, it's too complicated. That's why we don't use it in practice. I mean, either it's too complicated and whatever amount of data you give me, it's useless, or I'm going to make it extremely simple model, like a RIMA model, and then it won't be meaningful. So the question is that where do you sort of strike the right balance? And as I have only 2 minutes left, effectively, I'm not going to tell you about what precise model we use. There's a poster that Jahangir has outside, and there the precise algorithm is there. But that's an interesting question that was posed by this class of data, and we have a nice, I would like to say, it's a new time series prediction method. We put it to test, and here is what we find. Let me quickly parse the chart for you. What we did is that from data based on April to June of 2014, we trained our model, okay? Then we took a pause for 6 months, okay? And on data from December 2014 to April 2015, we used the model that we got from 6 months back, okay? So, and we just use that model to do prediction and run that simple trading strategy that I told you. Okay, and as a result, what happens is, okay, ignore these are precise number of ticks, but this is the price curve. It's oscillating around 2,000 yuan, and that's the cumulative profit. Okay, and the numbers that you want to take is roughly in 150 days with this much of average investment, that's the amount, say 7.5 times return, and with that Sharpe ratio. Okay, so it's a reasonable prediction method. Okay. Is this a lot of money? No, because I'm just trading 1 Bitcoin. So it'll pay for my coffee daily, but maybe not make me too rich. And now then, I can look at this and ask question: will this type of behavior I will expect in normal stock exchange? Most likely, no. So the question is that how do I figure that out? Well, if I had access to the data, that would be great. Freely, that way I can use it. And again, one message that I have is this is a great class of data sets, financial data. Access to that for statisticians would do a lot of good, both for statisticians and society, and maybe somebody will make money too in the process. One question, for example, that I would love to understand is what would be a good recommendation algorithms for investment? I know that sort of there's a good Yelp was mentioned in last talk. We have that sort of tells us recommendations for restaurants, or will be a good financial recommendation algorithm. And maybe I don't want to sort of recommend to others what I'm doing, because that's like giving away my signal. So if you are a Fidelity, for example, and I know there's a gentleman here from Fidelity, how would you share your data that you have from people? Okay, anyways, lots of great questions.
So I've got what's maybe a quasi-technical question for you.
Yes.
We've heard a lot about cryptocurrencies from you, some from Silvio. Will the primary utility of these currencies be the facilitation of the protection of ill-gotten gains?
Well, let me answer that with an interesting story. Okay, so as you would have guessed, I'm from India, and we have lots of interesting politicians. There's one particular politician in a southern part of India, Shah, has a lot of money. And there's a law in any reasonable democracy should have it. There's a law in India which says that effectively you can look at an individual's worth and look at it's like a box, look at the total amount of input and total amount of output. There's amount of money or value of the properties or things like that is reported to an individual. If that sort of exceeds what's the input, then there is a law that's broken, right? Unfortunately, she got caught under that law. Now, if she knew about this cryptocurrency, maybe she would have survived.
That's an encouraging thought. Is there a question from the audience? Yes. The microphone is on its way.
Yes, my question is, I have heard about this mining process, and I'm just very curious, like how you end up mining money out of nowhere.
Well, so I think that's a good point. I mean, so I'm not a Bitcoin expert, but here is one way to understand what these cryptocurrencies are, right? Cryptocurrencies are, in general, any currency, right? It's like an IOU node. And the question is sort of, well, I can write down here that I owe you a node, and then tomorrow you can come back to me and say, hey, you told me that I owe you $10, and I'll say, what is the proof? And then sort of maybe you want to have a proof saying that sort of my signature was there. Okay? So in some sense, you want to do this kind of thing at scale that is cryptographically secure. Now, when you bring that node to me, in our case, at least you and I can verify, but maybe you want to sort of involve John in the process of verifying whether that's, or I want to involve John in process of verifying whether that signature that I had made is actually authentic. So somebody has to do computation for the purpose of verifying that signature is authentic. Okay? And effectively, that computation should be paid. And that's how people are making money, putting it one way.
All right, I think we need to move on to the next speaker. Thank you, Devavrat.
Sure.